Circuit breakers and fuses, while both serving as overcurrent protection devices, operate under different principles. Circuit breakers employ a mechanical mechanism to interrupt a circuit, whereas fuses depend on a fusible element that melts and breaks the circuit path. The requirement for circuit breakers to open all ungrounded conductors simultaneously arises from the potential danger if only one conductor is opened. In such a scenario, the remaining energized conductor poses a shock hazard and increases the risk of electrical fires. Fuses, conversely, are designed to interrupt the circuit by melting only the specific fusible element subjected to the overcurrent. If one conductor experiences an overload, the corresponding fuse will blow, effectively opening that portion of the circuit even if other conductors remain energized. The National Electrical Code, specifically Article 240.15b2, addresses the requirements for circuit breaker enclosures. The NEC states each circuit breaker enclosure shall be marked to indicate whether the circuit breaker is designed to trip only for overcurrent conditions, or whether it is tripped for both overcurrent conditions and ground fault conditions. This marking requirement helps to identify the functionality of the circuit breaker. This specific code requirement applies to circuit breakers and not fuses, primarily because fuses are not inherently designed to provide ground fault protection in the same manner as some circuit breakers. Ground fault protection is a critical safety feature that detects unintended current paths to ground, helping to prevent electrical shocks and fires. Fuses primarily respond to overcurrent conditions, such as short circuits or overloads, by interrupting the circuit when the current exceeds a predetermined level. Circuit breakers, on the other hand, can be designed to respond to both overcurrents and ground faults. Circuit breakers that offer ground fault protection typically incorporate a ground fault interrupter, or GFI, which monitors the current balance between the ungrounded and grounded conductors. If an imbalance is detected, indicating a ground fault, the GFI will trip the circuit breaker, interrupting the power supply. Therefore, while fuses provide essential overcurrent protection, they lack the specific ground fault detection capabilities that certain circuit breakers offer. In summary, the difference in requirements between circuit breakers and fuses regarding the simultaneous opening of ungrounded conductors stems from their distinct operational mechanisms and protection capabilities. Circuit breakers are required to open all ungrounded conductors simultaneously to prevent shock hazards and electrical fires, a requirement detailed in the National Electrical Code. Fuses, while effectively interrupting overloaded circuits, do not have the same requirement because their design focuses on melting the fusible element in the affected conductor. Furthermore, the NEC addresses circuit breaker enclosure markings to indicate their tripping characteristics, particularly concerning overcurrent and ground fault conditions.